Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's workshop, brought to you by TechStrong and Influx Data. We have an exciting workshop ahead, but before we begin, I have just a few housekeeping notes. First, today's session is being recorded, so if you miss any of the workshop or you'd like to share it with a friend, a version of the on-demand will be made available shortly after our workshop ends today. So now, if you look at the right side of your screen, you'll see a couple options. First, we'll want you to be located in the Stage tab. And after that, you'll see Q&A, Chat tabs located underneath. The Q&A tab is where we want you to send in any questions that you have. And the Chat tab is going to be where we want you to just add to our conversation, give us any kind of feedback that you have in the moment. And finally, at the conclusion of today's webinar, we will have a giveaway of 4 $25 Amazon gift cards. I'd also like to point out that if you look in the comments section, I posted a link and it should be located at the top of the chat box. This link is a download link for the slides that are going to be presented today. So if you want to download those so that you can follow along on your own, that's where you can access that resource. So on to our workshop today. The topic is Build an IoT App with InfluxDB, and I'm joined today by Mirik Melecha, Director of Product Management at Bonnetu. And we have a supporting cast to help answer your questions of Charles Mahler, Maria Pollitt, Vlasta Hayek, and Ivan Kudaval. And it's my pleasure to turn the floor over to Charles to get us started today. Charles, thanks so much for being here with us.
Thank you. So just going to start off, I'll give us a brief little introduction before we get into the demo. So our agenda for today, for those not as familiar with Influx Data, InfluxDB, and kind of the time series ecosystem, we're going to start off with an intro to that. From there, we'll get into kind of showing you what the functionality of the thing that we're going to be building today, what the app can do, and then we'll install kind of the base product or the base project, and then we'll kind of build out some features. We'll go over how these queries work, how you can use the client library, and then we'll finally build out a real-time Jio map widget. And then finally, we'll cover how you can actually use InfluxDB to kind of monitor itself in a way where you'll set up monitoring for a Node.js app, just like the one we built. So InfluxDB as a kind of platform, the first thing is that it's purpose-built as a time series database for working with this exact type of data, like IoT sensors, server metrics, that sort of thing. It gives you better query performance, more scalable in terms of writing. Basically, it's designed exactly for this stuff rather than being a more general purpose database. Basically, there's numbers, easy to share, easy to extend. That's an aspect of it being open source. You can ingest from multiple data sources. We have tools that I'll go over to cover that, and easy to get started, but obviously you can scale it up as well. So our big focus is on developer productivity. So not just about the value, I guess, of the database isn't just the performance. It's also stuff like built-in functions for working with time series data, the ability to set retention policies, a lot of stuff that if you use another kind of tool, you'd have to create it yourself. You'd have to write a lot of extra code, and you'd have to deal with all that complexity. So this, with Influx, you get it right out of the box. We have our open source community, so you have tools like Telegraph, which makes it really easy to collect and integrate data. We have, as a result of our community, over 300 plugins. So like I said, you don't have to build a lot of stuff from scratch. Somebody's probably already using the same tools you are. They've already built these plugins to collect that data. And we have our templates, which are great for not only getting started quickly, but also just learning. You can kind of look at some of these community templates. You can see what they've done. You can kind of customize them, configure them, and get them for your specific use case. And this is kind of the overall, I guess, the life cycle, you could say, when you're working with this platform. So we have accumulating, you have could be an IoT sensor, it could be a container, it could be a server. They're generating all this metrics, all this data. The way you can collect that is with Telegraph, which has a bunch of different plugins. You don't have to write any code, you just configure it, and it just starts collecting it. We also have our client libraries, which we'll use in this tutorial. the JavaScript one in particular, but we also have client libraries for 11 different programming languages. And finally, we have Flux. So that's our scripting language, our query language. It gives you the ability to also, if you want to enrich that time series data, you can go out to a relational database and you can bring that in and get more information if you need that for your analysis. Once you have it stored in InfluxDB, we have functionality for alerting, for notifications. You can do anomaly detection. We integrate with a lot of different dashboarding tools, or you can use our client libraries to query that and create your own custom dashboards as well. And then finally, for our deployment options for this tutorial, like I said, if you read the emails coming to this, you should have your cloud account set up. That's really just to simplify this workshop, just because we don't want people on different operating systems with different versions. It adds a lot of complexity and a lot of potential bugs. So for this tutorial, you want to make sure that you have your cloud account set up. But we also have the open source that a lot of people use for local deployment, especially for IoT. They'll deploy it on the edge, and then they can do a lot of analysis right there on the edge, and then potentially export that to the cloud. So with all that out of the way, I'll turn it back over to Mirek.
Hello, let me continue with the next part, which is the introduction of the application called IoT Center. Just briefly, what is IoT Center? It's an application we develop for education purposes. So it's a very, very simple application that is not that wasn't developed for production purposes. So there are a lot of simplifications in order to show how you can easily integrate your application with InfluxDB, namely how you can query data from InfluxDB into your application in form of different dashboards, tables, and so on. We're gonna show you also how you can write data from your application or IoT devices into InfluxDB, as well as IoT Center is responsible for the management of IoT devices that are connected. So it is also managing the configuration of InfluxDB, because the devices are writing data directly to InfluxDB, and IoT Center is providing all the credentials, all the information that are needed to be able to access InfluxDB. IoT Center has been written using Node.js framework, and for UI, we are using React. We also added there some examples of the IoT devices. Later on, I will show you some details regarding this. And for this workshop, we're gonna use a special IoT device called virtual device, which is a part of IoT Center, which is able to generate data, some virtual data into InfluxDB in order to show how the whole ecosystem works. So virtual device is definitely something that we're gonna use today. So we don't need to connect real IoT devices, but the behavior is very similar. The whole application is documented. The source code is available, freely available on Git, as well as there is some documentation that is describing the specific functionalities of the InfluxDB. Later on, I will show you the details. As Charles mentioned, we don't need to install InfluxDB. We're gonna use Influx Cloud, so this will simplify the installation, and we will use it during this workshop. So let me start first of all with architecture of the whole IoT Center solution. So in the middle, there is an IoT Center, which uses the frameworks and all the stuff. We can control IoT Center over web browser. So part of this is also a web server, which is serving some web pages. Into IoT Center, you can connect more or less unlimited amount of IoT devices. And for each device that is connected to IoT Center, the IoT Center is providing the configuration, as I already mentioned, the credentials, location of InfluxDB, refresh rate, and so on. So there are a lot of information that are provided in order to reduce the information about the configuration in the specific IoT device. So except the address where IoT Center is running, you don't need to enter here anything else except this one item. Based on the connected sensors, IoT device can send some measurements into InfluxDB. Out of the box, we support temperature, pressure, GPS coordinates, humidity, CO2 level, and some others. This is typically sent over the InfluxDB client. Later on, I will describe what languages and what libraries we support. And the last component is the InfluxDB Cloud itself. So we are writing there all the data, or more precisely the IoT devices, as well as a virtual device, which is a part of the IoT Center itself. And in opposite, IoT Center is also able to load the data back into the IoT Center, and we can show the measured values in form of dashboards. So this is the architecture. And now let me briefly describe the main functions of IoT Center. First of all, you can register new IoT devices, either manually or automatically. So the device registration and the repository of devices is inside IoT Center. The second one is the virtual device that I already introduced. And the last one is the dashboard. There are multiple dashboards, but for this workshop, we will focus only to the first one called dashboard. Device registration, as I already mentioned, there is a table of already connected devices. In your case, there will be just virtual device, because once you generate the data, otherwise it will be empty, but you can connect there other devices as well. The second one is the virtual device, which is this page, which is showing some details regarding the configuration of the IoT device, as well as the latest measurements that we got from InfluxDB. What's the most important is the button on the top with pencil, which is responsible for the it can generate the data. It always generates data for last 7 days. Of course, if we have already generated the data, it will always look what is the latest day, and based on this, it will just generate the rest till up to now. And the last component is visualization. Visualization is showing both current values as well as the historical values. And now let me show the IoT Center itself. So this is the application which is running on my computer. There is a home page with some brief introduction, but what is important is this list of device registrations. If you develop your own device, and if the device will access the API of IoT Center, the new device will be automatically listed here as well. But you can also register the device manually if you want. It's also possible. You can, in opposite, remove the devices if you need. Once I remove the device is no longer able to send data into InfluxDB because the credentials will be removed. Virtual device is the second functionality. Here I have the latest values when I generated the data, and I can always run this button, and you will do this as well once we install IoT Center, and it will generate the data. As you see, it just generated 48 measurements into InfluxDB. So I generated this 48 minutes ago. In case you will run this first time, it will generate around 10,000 of points. The last functionality is a dashboard. The dashboard shows some basic information that in this case are generated by the virtual device. There is a filter and I can select which device I want to see. So this is the list of current values or the latest values, as well as here I've got some historical values. I can also switch to some longer or shorter period, like I can see last 7 days, for example. So now the chart density will be higher here. And I can also switch to another device. So if I want to see some measurements, of course, it's possible in case I've got some device. So here you can see the temperature generated by specific device, humidity. This device doesn't generate anything else, so the rest is not visible. By the way, it's mandatory that at least temperature must be generated by the device. So this is the limitation of IoT Center. So this is the dashboard. So now let me jump back to the presentation. Let me briefly introduce the source code. You already received the link in the chat to the source code. It's extremely useful to download the slides that I am using, because then you can copy paste all the commands into your laptop or computer easily, or console. And this is the organization of the whole source code. What's important, or the most important directory, is app directory, where we have the source code of the IoT Center itself. It's divided into 2 parts, server and UI1. Server is providing all the required APIs. UI means the source code for web browser, which is provided by the server. Then there is a client Arduino, where is an example of the IoT device that you can develop in Arduino environment, as well as we have a client or example of IoT device source code for Python. And as I already mentioned, there is also slides directory where you can download all the files that I'm sharing. So let me summarize what are the goals of the practical parts of today's workshop. The first goal is to accept, of course, the introduction and installation of IoT Center and so on. We're gonna add into the IoT Center a new visualization. It will be a map that will show the track of the device, IoT device. So we're gonna use Jio functionality of the IoT Center or InfluxDB as well. And the second, we're gonna also look to the monitoring of the applications, because this application or IoT Center is written in Node.js. We're gonna look how we can easily also get some runtime information about any Node.js application, but in this case, IoT Center. So we will see some nice dashboards or nice dashboard that will show the CPU utilization, memory consumption, different other resources utilization, like file system, for example, as well as we can monitor also the response time of all HTTP requests that were posted by the web browsers that are connected to the IoT Center. So this is the goal of the practical part. In general, the IoT Center is documented. Maybe you noticed if I return back to the demo of IoT Center, that on the right side, there is always some description, and there is always link to the source code. So I can click directly to the source code and see how the specific page is developed, as well as there is a link to the dev guide, where we are describing some key parts of the source code in order to understand how such application can be developed. Okay, so that's all from the introduction part, and let me continue with the first practical part, which is the installation of the IoT Center. So what we're gonna do here, we will first of all look how to create a InfluxDB Cloud account. Then we will look whether we have all the tools that we need to be able to run IoT Center and get the source code, of course, as well. Then we will, once we check the tools, we will get the source code from the Git repository. We will build the IoT Center from the source code. We need to also properly set it up with the credentials and all the information from your own InfluxDB Cloud account, because we need to somehow connect it to this account. And then we will run the IoT Center. Once we start the IoT Center, we will run the virtual device because we need the generated data for the next part of this workshop. We're gonna play with the data later on. So this is the agenda. Just if I use the architecture diagram, then we will start with the InfluxDB Cloud configuration, then we will install the IoT Center. Well, this is something that you should have already installed or prepared. You should have the InfluxDB Cloud account already registered, but if not, just let me briefly summarize what are the options. Once you open the address, you can register. You've got 3 options. You can either register through Google if you have the Google account, or via Microsoft if you have the Microsoft account, or in general, you can use any email. In this case, the installation is a little bit, or the registration a little bit more complex, because the next dialog that you will get is the email verification. So you need to look into your email, and once you receive the email, you need to click to the verify your email in order to get access to InfluxDB Cloud account. Once you confirm the registration, then you have an option to select what data center you want to use. You've got 3 options, either AWS or Google Cloud or Microsoft Azure. You can also select the location where you want to have the InfluxDB instance up and running. And then you need to enter the name of your company. And once you confirm the agreement, if you agree, you can continue to the next page, which is the selection of the tier. For this workshop, or even for some simple project, free tier is good enough. You don't need to pay anything. No credit card is required. So let's choose this option. If you already have some higher account, of course, you can use it as well. And then the next step is the initial screen of the InfluxDB. And now there is a slide deck, but I'm gonna use this or to do this together with you, because this is very, very important. We need to prepare the InfluxDB for the IoT Center configuration. So what we need to do is we need to register an API token. How to do this? From this initial screen, if you click to the 3rd icon in the left menu, here, there is an API tokens option. So let's click on API tokens. Yeah, third icon, API tokens. In your case, the table will be empty. In my case, I've got there some tokens, because my current registered devices, IoT devices, are using these tokens to access the database, InfluxDB database. And what we need to do, we need to generate a new token for IoT Center. So let's click to the icon or button called Generate API Token, All Access API Token option. Please select this one, because the IoT Center has to be able to generate new tokens for the new devices. So we need definitely this All Access token. And now let's describe it. So we can call it IoT Center, for example, and save it. Now let's please keep this page as it is. Please do not close this, otherwise you will lose the token. So please keep it as it is. Later on, we will copy paste the token from this dialog to the IoT Center. Okay, so let's continue. And now let's prepare our computers for the installation of IoT Center. In case you have a Mac, it's the easiest way is to use Brew package manager that is available on these machines if you install it, of course. If you don't have it, please follow the installation steps from brew.sh page, and then please run brew install yarn. Yeah, this is the command that will install the whole environment that we need. So this is for Mac. If you have Windows or Linux, we need to install all the stuff manually, or it's already pre-installed. Because this is a part of the prerequisite, I expect that this is already installed. If not, there is always some link where you can download the installation files, as well as you can get there the all installation steps. But just to be able to check whether we've got all we need, I will use both Windows as well as Linux, or well, Mac OS will be very similar if you use the terminal to test whether we have all the versions, the software that we need. So the first software is Git. So let's run git ---- version, and you should get some response with some version. The same for Linux. So I will do everything twice in order to give you some more time. Yeah, ---- So in both cases, I've got the tool installed. If you get command not installed or something like this, you need to follow the instructions from this address. The second step is we need to get the IoT Center. In this case, I strongly recommend to use the slide and copy and paste the command from the slide. So we need to run this git clone command. If you already clone it, I would recommend to just run git pull in order to update all the changes, but I expect that most of you don't have it yet. So let's paste the command into the console. So now I install it on Linux, or very similarly, it can look on Mac OS as well. In case of Windows, the same command, identical command. So now I have installed the source code of the IoT Center. The next step is just for Linux or Mac OS, we can run some package or some script that will check all the versions of the required tools and install them in case you don't have it yet. So let me first of all move to the right directory. So cd IoT Center /app, which is the directory where we spend most of the time. So we are in the core or root directory of the IoT Center server. And now let's run, no, not run, but tools. Let's run /tools.sh. It will check whether you have all the tools that you need. If not, it will automatically start the installation. And in some cases, it needs sudo password to be able to run the installation process in case of Linux systems. And it will automatically install also all the required packages that are required by the IoT Center. So this is the simplification. If you don't want to run this tool, or if you already installed all the stuff, you can also run these two commands to verify whether you've got all the versions installed. So let me run this on Windows side. So the first one is Node ---- version. If you don't have the version and if you get command not found, please follow the instructions from Node.js or org webpage, and the same for yarn. So you should get some version as well. Okay. In case of Linux, I can do the same. Yeah, so I can also run, in case you don't want to run the tools.sh, as well as, so if you already have it installed, you should get again some versions. Just be careful in case of Yarn. If you get version some number dot some number plus git, this version is not it's too old, so you need to upgrade it to some version that where are free numbers. Okay, so now let's install all the packages. We did it in Linux already using the tool script, but in case of Windows, we haven't done this yet. So if you have Windows, please move to the right directory, which is cd IoT Center /app. We definitely need to be in this address, in this directory, otherwise it doesn't work. And type yarn install. We did it in case of Linux. We can run it here as well. So if you haven't run the tools, you need to do it manually, and the yarn install automatically install the packages as well. It has been finished quickly because I have already installed the packages. You can run it as many times as you want without any issue. So in case of Windows, we are still installing this. So if you have Windows, I expect that you should get something similar. It typically takes around 1 minute to download it. It depends on the internet connection speed as well as the computer. So let's wait. And the next step that we're gonna do once we finish the installation of all the packages is the configuration of the startup script of the IoT Center. We need to enter there the information about your cloud account in order to be able to connect the IoT Center with the InfluxDB instance that you registered. So once we finish this, we're gonna update to one file. I will do it twice because I've got here Windows and Linux in order to show it. How does it look on Windows? How does it look this on Linux? Okay, we are still downloading. Okay, so for those who have Linux-based machine or macOS, let's start with the configuration of the IoT Center. We need to edit a file called dev.sh. Please feel free to select any editor. It's the file is already created in the app directory. And feel free to use any editor that you prefer. Yeah, I'm gonna use VI, which is the command line editor, and we need to enter there 3 values: influx URL, token, and organization. This is something that we will get from your account. The same for Windows, except the name of the file is dev.bat. So we can use, for example, Notepad to edit it. So here I've got a notepad, and again, I've got here 3 values that I need to enter. The first value, influx URL, we're gonna copy from the address bar of your browser. So please keep it as it is. Just copy and paste the address of your instance. Your address can be different. Yeah, it depends on what data center you selected, as well as what location you selected. Yeah, so please copy paste there your location from your browser. So paste it to the URL The same I'm gonna do for Linux or macOS. I will paste there the address. It's helpful to remove the last slash. Yeah, there should be only the address without slashes and the address after the slash. And so I copy pasted only the address, not the strings which are after the slash. The second item that I need to enter is the token. This is the token that we registered during the registration. So let's click on the copy to clipboard button and paste it to the token. So this is the API key that IoT Center will use in order to be able to access the IoT Center instance. And the last thing that we need to enter is Influx organization. This is a little bit different compared to the slides because the UI has been a little bit changed recently. And let's click to the second icon. And under organization, there is a settings. Second icon on the left and settings inside the organization. Not the first settings, but the second settings option in the menu under the organization section. And here, there is an organization ID, and next to the button copy to clipboard, there is an address of the organization or name of the organization. It's typically your email that you use during the registration. So let's copy paste the item from the web browser. Again, it's the second icon, organization and settings. And let's paste it to the file. So now I've got all three values that I need to enter, and I can save it. The same for those who have Windows. We can enter there the organization as well. So we entered three different values. Yeah, this is very important to copy paste all the values because very often you can do there some typos and we were getting some issues. So we can save the file and close the notepad. Okay. So we finished the configuration of the IoT Center. So we entered these three values, URL, token, and organization. And we can continue to the next step, which is the start of the IoT Center. Because both Linux and Windows is running on my laptop, in this case, I can run just one. So let me select, for example, Windows. And I will type dev.bat. So for those who have Windows, please run this command. In case of Linux or macOS, here the execution command is that/dev.sh. I am not going to run it, but once you enter it, you will see something similar like what you can see here. I've got a problem because I'm running another instance here. So let me stop it. Let me start it again. In your case, it should start without any issue, okay? It should also open a web page in some cases. Yeah, in some cases, it may happen that it's not started in case, for example, you are using virtual machine. So please type into browser localhost, this address, localhost port 3000. And now we have to wait. Yeah, it takes up to 1 minute to start the server. And after some time, you should see the web page of the IoT Center. The address is the one that you can see on my screen as well. It's localhost with the port 3000. The protocol is HTTP only, not HTTPS. If you have any issues, there are my colleagues that are ready to help you in case of any issue. Later on, I will show you some the most typical issues that you can get and how to fix them. But now we have to wait. We are starting IoT Center in development mode. The main reason is that during the next parts of this workshop, we're gonna update the source code of the IoT Center in order to add there the geo visualization. And in this case, you will see all the changes automatically without rebuilding of the application. So the start of the development server takes a little bit longer, but we're gonna use it later on. Okay, if you see the main screen of the IoT Center in your web browser, I'm still waiting for the start. Please select the virtual device on the left side in the menu, and please click on pencil icon. In my case, it will be faster because I have already generated the data, so you can do it. Yeah, it looks like here. Yeah, so you can click to the virtual device and click to the icon. I still have to wait. Okay, let's continue. It seems that in my case, it's gonna start longer because my laptop is also sending the video and all the stuff. So it seems that it's a little bit overloaded. So in your case, please click to virtual device and click to the button, top right screen, which will generate the data. And now let me describe some typical issues that you can get. If you click to the virtual device and you will get some error message like this one, this is the list of the typical issues that you can get. If you get connection refused with this address, with the 127.0.0.1, it typically means that you haven't saved the file with the configuration, independently whether it's the dev.bat or dev.sh. So please save it. Yeah, typically this is the typical issue. If you will get some error like organization name not found, it typically means that the Influx organization hasn't been entered properly. So please copy paste it, not retype it, because in many cases this is the main issue. It's typically the email address that you used during the registration. If you get something like unsupported protocol, it typically means that in Influx URL, you haven't specified HTTPS prefix and you copy only the address without HTTPS. Please enter there the whole address, but after the slash, it should be empty. The first slash after the address should be removed, including the rest of the string. In case you will get address info doesn't exist, it typically means that you did some typo in the name of the server. Again, please copy paste it from the web browser. The last issue that you may get is unauthorized message with invalid credentials. In this case, it means that the API token that we generated wasn't correctly entered here. So you've got two options. You can either create another token like we did together and generate another API token. If you even lose the address because you close the browser or the window, please open InfluxDB. You can generate another token. Once the token is generated, there is no option to see the token. In this case, please delete the token and create a new one. And then you can copy it, paste it. Hopefully my IoT Center already started. Yeah. So I can click to the virtual device, as I already mentioned, and click to write missing data. As you see, 31 measurement has been written. In your case, it should be more than 10,000. Then if you run it again, of course, it will be just one or few. Okay, so my instance has been started as well. If you have any issue and you don't know how to solve it, please contact my colleagues over the chat. They should be able to help you. But during this time, let me continue with some tests. First of all, we can test whether we generated the data by the virtual device. So if we click to the IoT Center and click to the dashboard, the fourth item, you should see some values. You should see some historical values. So you should see something similar to what I have on my screen. Okay. And now let me briefly introduce some information regarding the IoT devices where we edit some source code in order to show how you can develop the IoT device that is writing data directly to InfluxDB. We delivered two. The first one has been developed for Arduino environment. We support two hardware platforms. Both are based on ESP chip. It's ESP8266 or ESP32. And this client is able to connect the IoT Center, get the configuration. There is also support for the most common sensors that you can connect. You need to enter into the source code the address of Wi-Fi network where this device will be connected, as well as in the second file, you need to define what pins were used to connect the specific sensor. Once you do this, and once you run the device, you will see the registration in your IoT Center. The second platform that where we develop also some example is for it's written in Python, and it can be run, for example, on a Raspberry Pi. Again, the Raspberry Pi needs to be connected with some sensors in order to be able to generate the values. Of course, you can also fake it like a virtual device and send there some random value or generate some function. But the main purpose of this to connect there the real sensor and send some real data directly into InfluxDB through IoT Center that will provide the configuration information for the specific IoT device. So feel free to look to these examples. We also develop a simple mobile application that can be connected to IoT Center. It can be started on both iPhone as well as Android-based devices, and it can show some basic information like the basic dashboard, as well as we support the device registration. And now let's have a 5-minute break to solve potential issues in case you are not able to run IoT Center. We definitely need to have it up and running with the generated data. Anyway, if you are not able to run it, you can follow also the my screen, because I'm going to do all the stuff with you on my laptop as well. So let's I will return in 5 minutes. Okay, so I hope that all of you have IoT Center up and running on your computer. And let me continue with the next part, which is focused to Data Explorer. The Data Explorer is a component inside InfluxDB that can help you to understand what's to browse the data that you stored into InfluxDB, and it's extremely helpful tool also for development. So this is what we're gonna do now. So we will log in into InfluxDB, and the way how you can get the data from InfluxDB, there is a language that can help you to query the database data. And the last task in this case is how we can create a query that will provide a geodata, latitude and longitude GPS data that can be provided by the IoT devices. So this is the plan. And now let me start with the Data Explorer. I'm not going to use slides now. I will use directly the InfluxDB. And how to access the Data Explorer. It's the fourth icon in the left side with the chart in the icon. So this is the Data Explorer. And now how you can query the data. The easiest way how you can query the data is to use the wizard, which is on the bottom of the screen. Yeah, so let's select some key items that we need in order to get the data. So the first step is we need to select bucket. Later on, I will explain what does it mean. Let's select IoT Center. It should be already selected. If you don't have IoT Center in the list, it means that you haven't generated data through virtual device. So please generate the data. If you are not able to install IoT Center, then it will be empty, and please follow just the steps on my screen. So IoT Center is the first step. The second, we need to select the measurement. In this case, it's measurement called environment. Then this is the filter. Now we're gonna filter the device ID. So the client ID equals virtual device. In your case, you will have there only one item. In my case, I got 3 because I got also IoT devices connected to my IoT Center instance. So please select virtual device. And now let's select the specific measurement that we want to see. It's called underscore field. And let's see, for example, the temperature. And that's it. So IoT Center, environment, virtual device, temperature. And now let's click to submit. So here you can see the history of the temperature generated by the virtual device. This is, you can switch also the window. This is the 1 hour history, but I can switch to some longer period if you want. This is, of course, still possible. Now, let's look to the Flux language. Yeah, so next to the submit button, there is a script editor. So let's switch to the script editor, and you will see a command. So the wizard, the query builder wizard, generated this command that has been executed by the clicking to submit, and the data has been transferred back to this dashboard, and we see the history of the data. Now let me jump back to the presentation, because I will explain in detail the purpose of each row in the command. The first row from bucket IoT Center defines that we would like to use a bucket IoT Center. Bucket, in case of the standard SQL database, is something like database. But in this case, it's also a database with a retention policy, which defines how long you want to keep the data in the specific database. The second row is called range from some starts, and there is a time range start, time range stop. Everything which begins to v dot something is a variable that is generated by the dashboard itself. So in this case, these values are defined by the selected filter. Yeah, like we selected 1 hour, but we can select it something more, and these variables are automatically updated based on this filter. The next row, and it's something like where in the database, yeah, so we can define the time limitation. The next one is measurement equals environment filter. Measurement underscore measurement is something like database table. It's not completely database table, but it's very similar. So here we are defining what database table we want to query. The next one, underscore field equals temperature, means I would like to see specific column called temperature. So it's a filter that which defines what column I want to see. And the next row defines client ID equals virtual device, which is something like varchos in SQL. Yeah, so we define the filter, what rows we want to see, only the rows where the client ID is virtual device. And then there is an aggregation that we need in case we want to show the history, and the history visible in a dashboard is it has a different density than the data that we have stored into InfluxDB. So here we are defining how to aggregate the value in order to properly show it. So the window period is something which is calculated by the dashboard itself. Then there is a function that we're gonna use mean aggregation function for the data. So if we have more values than what we can show, this function will be used. And that's it. Yeah, and create empty means if there is no value, then you either have option to create empty values or just connect the values which are visible. So this is the query. Now let me jump back to the InfluxDB UI, and we're gonna play with this UI. We're gonna continue. The next very interesting capability of Data Explorer, which is very, very important in case you want to develop against InfluxDB, is view raw data. There is a switch almost in the middle of the screen. If I click it, instead of the visualization, you can see a table. And this format that you can see here is more or less the same. If you run the command from your application, you will get some CSV format that looks like this. This is the structure. So here we have the history of the temperature. We've got the time that is important, and you can see there are some additional values that has been provided by the IoT device, like what sensor has been used for the measurement and so on. So by this command, you will get the table. And if you want to understand what data you will get from InfluxDB, the most recommended first step is to look into Data Explorer, debug the functions here, and then take these commands and use it in your application. And now we have a question, or I got a question, how to change this command in order to get GPS coordinates instead of temperature. We've got two options. We can either adjust this command, or we can switch back to the query builder wizard, and here adjust the query. So instead of temperature, which is here, we can select latitude and longitude, let and long fields that are provided by the device, virtual device. And that's it. Yeah, and if I run it, you will see that we got, instead of temperature, we got longitude. And if I move to the next pages, we see also latitude. So we can use this wizard, or we can adjust the command. And as you see, the only difference between the previous one and the current one is that we selected different field. So instead of temperature, we want to have latitude, lat, and long. You can see that we can also use OR operator if we want to have multiple columns, like in this case, and we get all the data from InfluxDB. So this is something that we're gonna use later on in our practical exercise, where we will add a map into the dashboard. So please remember this, because we will need it later on. Now, the last thing I would like to share with you is that the Flux language is not just for querying of the data. It's a full language that can be used for the transformation, for some filters, for creation of the data. So it's a full language that can help you to achieve what you need to do with InfluxDB. There is a documentation on this page where you can get some more detailed information about this. So this was the brief introduction of this language. And let me continue to the next part, which is how you can interact with with InfluxDB from your application. More or less, you've got two options. You can either call directly the APIs of InfluxDB, like this example. So this is the example how to write the data into InfluxDB. So we can use HTTP post request. In this case, this is the address. You remember that we needed to define organization and bucket. So it's the same, as well as token, which is here. Yeah. So all these three values that we entered into Influx into IoT Center configuration, we need to access the API as well, which is natural. And then there is a sentence which defines the data. We call this format line protocol, and this line protocol has some mandatory and optional parts. The first item in the list is the name of the measurement. Like in this case, it's CPU load short. Then there can be a list of something we call tags, which are indexed columns of the more or less table where we are writing the data. So here, this is the typical way how you can define, for example, where this CPU measurement has been measured. So in this case, server 1, you can use the region, you can use any string that you want to store together with the value. Then there is a value. In this case, it's a CPU load value. And then there is an optional part, which is the timestamp. Here we are defining what is the time of this measurement. In case I mentioned that it's optional, if you don't specify it, the timestamp is automatically defined based on the time when this record is received by InfluxDB. So we've got this option, but of course, if you use directly the API, it's not so much user-friendly, because if you, for example, want to retry the sending of the data because of some issue, or if you want to improve the performance and send multiple values at once, and so on, it's quite challenging to do it through APIs, as well as to, for example, register new bucket or token and whatever. So that's why we develop a library that is simplify this and make this much more smart. And this is the list of libraries that we developed so far. So this is the list of supported languages. These libraries for each language are very similar. So typically the interfaces and the approaches are very similar. And if you know how to do it in, for example, JavaScript, you will know how to do it in C# as well. It's very similar. There are some differences, but we develop this as similar as possible. Now let me focus mainly to the JavaScript library because this library has been used by the IoT Center. And as I already mentioned, it's quite similar for other platforms as well. In case of JavaScript client library, there are two main packages. The first one is called InfluxDB Client. And this InfluxDB client is responsible for writing of the new data into InfluxDB as well as for querying. So just these two basic operations. This client can be started on in web browser as well. So you can write the data directly from the web browser as well using this library. That's why it's also separated into two packages. The second one, the InfluxDB client APIs, is responsible for the management of the configuration of InfluxDB. So if we want to create the tokens, create new measurements, no, but buckets, for example, this is the right package. You can also do the health check there. There are a lot of examples that are available, which are showing each operation, what you can do with this library. Of course, there is also the API documentation. Now let me show some basic operations. The first one is how to write the data. So here, this is the list of definition of some basic constants that we gonna use if we want to connect the InfluxDB database. So there is an InfluxDB command with some parameters like the organization bucket and so on. NS means that the timestamp will be in nanoseconds. We can also define something called default tags, which is the tag which is automatically entered into all writes. So I don't need to specify it per write. Typically, if we want to add there, like in this example, a host name, this host name will be visible everywhere. So if I am just writing one value, the whole host name will be included as well. And then we can create something called point. The name of the measurement is temperature. We added their additional tag called example, and there is a value. It's a float value, and there is a random function which is generating the current value. Then we can write the point. So the function which is writing the point contains typically 1-2 rows. First of all, we need to create a point structure that we will write it to using write point. Another big benefit is that, for example, in case of JavaScript, it's non-blocking, so you don't need to wait for the finishing of the write. It does the buffering as well. So if we want to save bandwidth and improve the performance, the library, you can define the size of the buffer, and the library is able to send data in batches. As well as if the server responds that it's overloaded and you should wait, or the server is not temporarily accessible, the library can retry automatically the connection and send the data to the server. So there are a lot of advantages if you use the library for writing of the data. If you want to query the data, the approach is very similar. First of all, we need to connect the InfluxDB, get the query API, and then define the Flux query. If you remember, this is very similar to the command to the one that we used in Data Explorer. As you see, you can write it on one line as well. It doesn't need to be multiple lines. And here you can define the command itself. Then there is a query row function where I define the query itself, and then I am processing the rows of the response, as well as I can handle the errors, and I can handle once the transfer has been finished and we got all the rows. So very simple way how you can query the data. This example is using the management API, the one that cannot be executed on the browser side. And here, this code is creating the bucket. If the bucket already exists, the bucket is deleted and recreated again, which means that also all the data, all the measurements within the specific bucket will be deleted. So in this case, first of all, I need to get the list of organization. I need to select the right organization. In this case, I select the first one. Then I will get the bucket API, get all the buckets. If we see that there is a bucket that equals to the name of the bucket, which is the example bucket, which is here, then the bucket will be deleted. Yeah. So here we are searching the name. If we get the bucket with this name, we will delete it. And then the next function is create the bucket, or post the bucket. It's named post the bucket, but it creates the bucket. So very similar functions are there for creation of API tokens and so on. Documentation, I already mentioned, it's on the GitHub. All the libraries are available on the GitHub, including the documentation. So this is the interaction of client library. So if you want to develop your own application, there is a high probability that you will find the proper library as well. And now we've got the second practical part, which is the adding of the visualization into IoT Center. Currently, if you remember, in the dashboard, we have the current values and we have historical values. But we don't show the location history that is also supported by IoT Center, that even virtual device is providing, but we don't see it in the dashboard. So how we can add this map into the dashboard is the goal of this section, of this part. So if we do everything correctly, you should see a map with the track of the virtual device. How to do this? Everything will be done in one file called dashboard page, which is under app UI src pages. So we have to move to this directory and open this file. So let me open command line, not Windows, but Workshop. IoT Center /app/UI. The same is on Linux, yeah, the address is the same. So from the directory where you install it, src pages, and that's it. So this is the directory. And now we're gonna edit a file called dashboard page.tsx. You can use editor. I am going to use Notepad because Notepad is in all Windows machines, but you can use anything you want. And what we're gonna do, first of all, we need to update the query to the InfluxDB. Yeah, if you remember what we did in Data Explorer, we need to add their latitude and longitude because these are the fields that are providing the location of the device that is stored into InfluxDB. The second step is adding the visualization itself, which consists of 4 steps. First of all, we need to add the imports, just 2 lines. We're gonna use leaflet library, so we need to do the import of this. Then we need to create the visualization components where we need to bind the data from the InfluxDB query into the format that the leaflet library is able to process. And the last step is to add the newly created geo visualization into the dashboard itself, which is 1 row. Very simple. So the first step is to add there the GPS coordinates, let and lon. So this is the command that you need to do in your case to get the location of the device. just the green part. Yeah, so let me copy this from the slide deck, open the notepad and scroll down. And once I see the command, I can extend the existing command by this. So after the CO2, between the CO2 and the last bracket, please add there or field equals let or field equals lon. So this is the command, and we can save the file. So this is the first step. I have already mentioned that this is not for production purposes. As you see, there is a one command which is getting data for all the visualization, which is typically in production application not the suitable solution because it would overload InfluxDB instance if there are many people which are accessing the dashboards. So it's much more suitable to define the data source per each component. And especially for Jio components, it's also very helpful to use Jio functions in InfluxDB that are able to select only the region which is visible. So let's say this is the whole track of the device, but we are showing only this small part. So we don't need to get all these points which are showing the whole track. We just need this small one. So the filter that is defined on the top of box is able to select only the data and provide the data which are visible in the visualization. So this is one of the changes that you definitely need to do in case you want to use it in production environment. The second step is to add there the library. So as I already mentioned, we need to import their leaflet library. So React leaflet library is the library which is providing the component. So in the beginning, after the imports, let's copy paste there 2 additional imports with the stuff, the green stuff which we have in the slide. So now we have the additional 2 imports in the file. And then the next step is the definition of the component. The component consists of 2 parts. The first one is responsible for the transformation of the data from InfluxDB query into the format that is accessible by leaflet library. This is the transformation. So from the measurement table, we will get these 2 columns. We will merge them together, and we will provide this into the leaflet visualization component. The second part is just the configuration of the map itself. So what is the zoom? We're gonna show the track zooms level, as well as here you need to also define the address of the tile server, which will be used to show the map behind the track. So this is the address. We are going to use OpenStreetMap that is available without registration, but it's limited. So let's copy this and let's put this before the render plot function. So let's move to the source code, try to find ren plot, which is here, and let's paste there the definition of the component. So I copy pasted the whole code from the this slide, the geo definition, and after this there is a render plot function. And again, save it. So I copy pasted this code into the page. And the last step is to add the Jio component into the dashboard itself. So if I move to the end of the file, so let's move and add this Jio component into the right place. So there will be the current values, then there will be the Jio component, then there will be the historical values. And again, let's save it. So now let's open the IoT Center, and you should see the difference. So now you can see the track of the virtual device. So by just adding four lines or four sections into the dashboard, we were able to add additional visualization into the dashboard. We did the imports, we adjusted the query, we created the component itself, and we placed the component into the dashboard. And that's it. Of course, if I change here the filter and I will, for example, switch to 7 days and wait for the response, you will see that the track will be much longer, almost the whole US in 7 days. I can zoom, I can see the details. As you see, it's really running on the specific route. So this is the 7 days of history from the virtual device. If you have, of course, the real device, which is providing the GPS coordinates, you will see the historical data as well. Okay. So in case you are getting some issues, you can also, instead of adding everything manually, you can run this git checkout command that will update this page directly from the repository. So all the changes that we did together are done there as well. So by running this command, you are able to update the dashboard page, and you will see the map. In case you don't see the map, please refresh the browser. Yes, sometimes the browser is not automatically refreshed, and it needs to be refreshed manually. Again, if you have any issues, please contact my colleagues through chat, and they should help you with this. And I give you additional 5 minutes time to fix the issues and play with the IoT Center. After that, we will continue with the monitoring of the IoT Center. So let's have another 5 minutes break. So let's continue with the last part, which is Node.js monitoring. And what we're gonna do here, we will look how you can monitor the processes inside Node.js applications. Then we will look how we can do the monitoring of the response time. And then we will also look how we can quickly create the dashboard from templates in InfluxDB. So using a few clicks, you can build nice dashboards which are predefined in the repository. And then in general, I will show you how you can use the monitoring that has been created for IoT Center in any Node.js application. There are just only 2 steps, 3 rows of the code, and 2 files that needs to be copied from the IoT Center, and you can do the similar outputs from any Node.js application. So how we can monitor the Node.js processes? Yeah, in the beginning we need to connect the InfluxDB, so it's very similar to the command that we saw in the Node.js client library. And then the most important part is here. There is a process, memory usage, CPU usage, and resource usage, which are the standard commands in Node environment. And we can write the point, which is the list of information provided by these 3 commands. In order to do this, we need to have some transformation function, which transform the format provided by these process functions into the format of the point. The create point function is on the right side. So as you see, it creates the point with the name of the measurement, which is the node memory, node CPU, and node resource usage. And here we are just translating the specific keys into the float fields. So this function translates the format of the process. By default, the process information is generated once at 10 seconds, but you can, of course, change this into the configuration. The second example is showing how you can get from the Node.js application the monitoring of the HTTP requests. Yes. Again, we use the function which is providing the response time structure. Based on this, we create a point. In this case, we call it express HTTP server measurement. And under this, we will create three tags which are defining the path where of the request, like you can see here, the path. Then there is a method, whether it's a get, post, or whatever. And the last thing is the status. Yeah, the status code is the number of the response in HTTP protocol. And then there is only one field, which is the measurement. It's a response time. And it's the time, how long it took to process the specific request. So very similar what you can see in the log of your application is also generated into InfluxDB. Very similar things you can do in any application. The only thing you need to do is you need to copy or everything is embedded into these two files, monitor.js, where is the whole logic, and there is also env.js, which is handling the configuration of InfluxDB, where the InfluxDB is located and so on. It's the same code like what we did in the installation of IoT Center, so it can use environment variables to override the values. And then in your application, if you want to use this monitoring, you need to only add this row, import from the monitor, and then in the start application function, add the monitor response time and process monitoring. That's all. So only 3 rows of the code and 2 files is good enough to do something that you will see in few minutes. In order to show or quickly add into InfluxDB some specific monitoring solution, it's extremely useful to use something we call templates. The template is a definition of the configuration of the dashboard, of the query, of the data source, and so on. That is embedded into one text file that you can import into InfluxDB, and all the dashboards, queries, and configurations are automatically created. And there is a page where you can see and you can even contribute, because it's a Git page where you can see a lot of examples. And one of these examples we're gonna download. So let me open the InfluxDB UI, and you can do it as well. Yeah. So this is the InfluxDB UI, and let's click to the last item on the left menu. And here, under the submenu, there is a templates option. So let's click to the templates, and we see this dialog. What is extremely useful is to click the browse community template. So let's click on this, and it will open another tab in your browser, when you can see the list of templates. So let's find Node. So there is a Node.js directory. I can click on this, and here I have the example of the dashboard, or picture of the dashboard, as well as I have here the whole procedure how you can install this template. But let's do this together. The first step you need to always do is to select the YAML file which contains the configuration. I can click on this in order to show the structure. So here you can see the definition of all objects. And what we need is to copy the whole address. Now the whole address. Yeah. So let's copy this from address bar, and let's paste it into the dialog in InfluxDB. The address of the YAML file in the Git repository. As you see, it shows that we are good to go, which means that it's correct. And we can click to the button called Lookup Template next to this Edit button. And here you can see what we're gonna import. So there will be one dashboard called Node.js Application Monitoring. There will be one bucket called IoT Center, some variables, labels, and so on. So this is the content of the template, and I can click to the Install Template. Okay, I click it twice, it seems. And the template should be installed into, okay, let me do it again. Lookup Template, install. Okay, it seems that currently it doesn't work. Yeah, it's already installed anyway. So once you install it, it will automatically create the whole dashboard. Yeah, so the whole dashboard, it seems that it hasn't been installed completely. I see. So let me delete this. Okay, SQL instance, and let me install it again. Anyway, I recently removed the values from the InfluxDB, so it seems that I haven't deleted everything. So there is some issue. But in your case, you should see a dashboard with Node.js application that looks like the example which you can see in the deck, which is this one. So you should see something like this. There is some information regarding the response time, average, maximum, minimum, the CPU usage, heap usage, the system I/O operations. This is the response time measurements. You can even click to the specific column and it can be sorted according to the values. So you can see, for example, the maximum response times. There is also some threshold when the specific value is highlighted. So all these things can be imported through the template. You can, of course, look also how the specific template is created. And based on this, you can, it's really strange. Yeah. So it doesn't work. Another template that I can also import is the IoT Center itself. Hopefully this template will be properly imported. So instead of Node.js, let's try to find IoT Center. We'll see whether this is related only to this template or whether there is some more generic issue. And we copy the IoT Center YAML file. So let's copy this. Let's move to the Influx Db Ui, and let's install the template. It seems that in my case, it's really broken. But what I wanted to show is that you can also use the templates to install quickly your own installation, and you can build very quickly. Also, the dashboards that you saw in the IoT Center, also in InfluxDB Ui. So the InfluxDB Ui itself contains the dashboards, and you can use the community templates to import these templates into your instance, and you can connect based on the installation instructions specific technology that you want to monitor into InfluxDB. As you see, the list of these technologies, let me show the table, is pretty wide. So there are a lot of different systems and technologies that you can integrate. And if you have something interesting, of course, you can in opposite export these dashboards back to this repository. And once the specific new dashboard is approved, it will be visible in this list as well. So if I want to see, for example, Windows system monitoring, here I can monitor the machine, Windows machine, and here is the set of instructions what needs to be installed and how in order to get the values. Typically, if you want to monitor some system, you need Telegraph, which is another component provided by Influx Data, which is able to capture the data and push the data into InfluxDB. In case we are writing the data directly through the client, of course, the Telegraph is not needed. Okay, so that's all from my side. Are there any questions or some common issues that we should answer?
Doesn't look like there's anything in the chat right now. If anybody has anything related to the presentation or just anything about InfluxDB, if you have a question, feel free to put those in the chat now. It looks like, as far as those template issues, it might be related to region. So we'll have to look into that, but I'm assuming that'll be like a short-term thing, and you can obviously check back in if you want to play around with those templates. If there are any, I guess we can move ahead. If you do have any questions later, we have our Slack channel, so you can go to our community Slack and ask them there. We always have lots of people around to answer your questions. We also have our community forum and GitHub. So those are all good places. If you have questions or just want more information, you can check those out. Again, like the next steps you're going to want to take, keep playing around with IoT Center, play around with your free cloud account, use that as inspiration to kind of take to the next level and take some of those as like an architecture pattern and use it for your own project. And then try out some of those templates later again when we figure out what's going on with that and why we can't import them. You can go look through that whole gallery of our community templates.
Awesome. Well, seeing that there are no more questions, I'll go ahead and let our audience know that the session was recorded. And if you missed any of the session or you'd like to share this with a friend after the fact, the on-demand will be made available shortly after we conclude today's webinar. You'll receive an email with a link to access that on-demand. So don't worry, we'll get that to you. Mirek, thank you so much for being here with us today, for sharing your expertise, for putting together this demo. Seems like we had quite a few people who were actively engaged with us today, and so that's really exciting that people were able to use your demo and actively learn from it in a real time thing, because that's not something that we get too often in the virtual space anymore. So Mirek, I really appreciate you taking the time to be with us and putting this together. On to our 4 Amazon gift card winners. This is for $25 gift cards. The first winner is Tony L. Our second winner is Deborah W. Our third winner is Rommel R. And our fourth winner is Hiratsu I. So congratulations to the 4 of you. Keep an eye on your inbox to claim the gift card. And if you don't receive an email, just check your spam folder. My next thanks goes out to Influx Data for hosting and sponsoring today's webinar. And my final thanks goes to you, our audience members, for being here for this live presentation and live demo. So I really appreciate you all being here. Have a great day. And this is Cody J. Brown signing off.